Factoring a difference of squares. Sounds ominous, but it's not. Most people who learn factoring believe this is the easiest of the factoring. While it's happening, you might not believe me, not till I finish and start actually doing examples, then you'll believe me. To warm up for this, we want to factor 1, 2, 3, 4. Varying difficulties ones. Let's just review where we're at before we jump in. I'm going to give away some of tomorrow's lesson. Tomorrow I'm going to teach. When you go to factor, there's a first step. Does anyone know what the first step to look for is? First look to see if there's a common factor. That will be true from now on. Yes? That's weird because I didn't teach. Sometimes I taught common factoring and then I taught something different and sort of forgot about common factoring for a bit. We've got to bring that back. That's what reasoning is all about. It's called, can I common factor?
What is factoring?
What is factoring is breaking something into two things multiplied together. So when we factor like the number 10, we factor it into 2 and 5. Now it got out of hand here because the expressions we're talking about are a lot more complicated than just 2 and 5. But factoring is just break it into things multiplied together.
So what is a factor?
A factor is a number that divides into the original term.
Okay.
Yeah, good. Great questions. So after deciding if there's a common factor, then me personally, I look to see, is it a simple trinomial? I don't know if that's the easiest of the factoring, but it's the one that people get the best, I think. This one is simple. How do we know if it's a simple trinomial? Which term decides if it's simple or complicated? Yeah, there's no number in front of x squared. Well, there is technically, I guess, a 1 in front of x squared, but there's no number that's going to affect what we're doing. So when that happens, all we're looking for is what multiplies to 45 but adds to negative 14. She's fast them, and she knows she's fast them. You see how fast her hand rocketed up there? She's like, I got it. Some of you found that with smaller numbers, you could do it in your head, and you probably couldn't even explain how you knew. You just like, boom, I know the numbers, because your multiplication tables are that good. Then when you got to bigger numbers, you were in trouble because you didn't have a strategy. So I'll continue to show the strategy. The strategy is to go, okay, well, 1 and 45 multiplies to 45, but doesn't add to 14, clearly. 2 doesn't divide into 45. Hopefully, you don't need a calculator for that. You're like, well, it's not even, so it's not going to work. 3, and if you're stuck, you're like, well, what multiplies with 3 to get 45? Your calculator will tell you 45 divided by 3, and you get the other number, which is 15. That doesn't add to 14. 4 doesn't divide into 45. 5 and 9, oh, negative 5, negative 9. She did that very quickly, folks, so she's all over those somehow, some way. And then those are the two numbers we use to factor the two sets of brackets. Is it okay? Is it okay? Okay, so I'm already teaching tomorrow's lesson here as I go. First step on the next one. Check for a common factor. Let's get the numbers smaller if we can. Is there a number that divides into 3, 3, and into 36? Yeah, 3 divides into all. The one to check first is the leading coefficient. Let's just, if that one goes, we're happy. So we grab that one. Yes? The quiz and a lesson tomorrow. Yeah, it's a short lesson. Because I'm giving away a lot of the lesson here. The lesson's just on reasoning. It's like, how do I decide on, and I'm doing that right here. Like I don't know if it needs a separate lesson or not, but you're right, yep. So take the 3 out, and once I take the 3, that factor out, then I divide all of the terms by the 3 because I've taken that factor out of there. Yes? So each of those terms gets divided by 3. So I get x squared minus x minus 12. Maybe you need your calculator to divide those out. Great. After doing that, I'm hoping for a simple trinomial. I look to see, is it a simple trinomial? Yes. What's left is a simple trinomial. So now I'm looking for the two numbers that multiply to negative 12, but add to negative 1. Yeah, when it's not there, it's a 1. Negative 4 and positive 3. And as she said that, we got a little view of the inside of her brain, I think. Maybe she didn't even realize. We got to see her thinking there. She went negative 3 positive, no, negative 4 positive 3. Yeah, that's actually the right thinking. Where you go 4, 3, negative 4. You just, people are frustrated with this. Like, tell me you got something better than trial and error, Mr. Todd. I don't. Yeah, I don't. I don't have something else I'm going to teach you later on how to handle these. Whoa, that's dangerous. Ooh, is it right? How could we check if it was right? Just FOIL it back out and make sure. Okay. Through the reasoning again, totally teaching tomorrow's lesson. First, check for that common factor. No, this one doesn't have a common factor. 2 doesn't divide in all these. Then, check to see if it's a simple trinomial. It's not a simple trinomial. Complex trinomial. So you've got to have something in your bag of tricks for these. We have decomposition. We've got window. And we've got just use our brain and see if I can get this thing to work out. Let's take the survey to see where we're at. How many people are now, after doing some practice, are decomp people? How many window type people are there? Oh, I love window. Yes, I love window. Anybody now at the point where they're like, oh, I'm just going to figure this out? You don't have to be. You never have to be. Yes, I just taught it in advanced functions yesterday, and we just talked about it, and I said, whatever way you handle this is fine. Here's the answer, as long as you can get the answer. Each teacher might not teach each individual method, though, so you better have your method down pat. So, in both decomp and window, I go over here and I figure out what AC is, which is 24. I make a list of everything that multiplies to 24. See, it's sort of like the other method. You get to just find these multiples. What multiplies to 24 and adds to a negative 11? Negative 3, negative 8. Multiplies to 24, adds to negative 11. I use that to break that middle term up. That's a very mysterious step. If you're still mystified by that, well, good. That is a little bit mysterious why we do that. But what we found is the perfect combination of numbers that will make this common factor nicely by factor by grouping. So you common factor the first set. I think I get x. Common factor the second set. I take negative 4. And if everything's gone well, the bracket's the same in both of them. And maybe you can just stare at it and see them now. 2x minus 3. Can you see the x minus 4 just sitting there in the middle of it? What you're really doing is common factoring out 2x minus 3. Leaving, after you take that away from each term, x minus 4. But I encourage you, with time, on the quiz or the test, to go back and go, let me just distribute this out again. Make sure I got it right. Yep, it all worked out. Beautiful. I got it. Well, I threw this one on here. I don't know if I'd ever put this on a quiz or test, but I just threw it on there to go, this actually extends and we can do more difficult questions than we've seen so far with just the methods we have. If we just open our brain just a little bit and go, you're like, I've already opened my brain enough for one chapter. Thank you very much. So I don't want you to panic about this one, but I want you to see it. I want you to see where this is going and some of the work we can do here. First step, common factor. Is there something common to all these? No number divides into all these. What about x's? Oh yeah, there's an x in each part, so x comes out of each part. What about y's? Y cubed, y squared, and y? I can take out a y as well. And when I take out xy, I get y squared plus 2y plus 1. Ah, see, it looked disastrous, didn't it? It looked like, what? Well, once you take the common factor out, you get left with something that isn't very manageable. That's a simple trinomial. Two numbers that multiply to 1. Is that enough already? As soon as I say two numbers that multiply to 1, you're like, I already know what they are. So many two numbers that multiply to 1. Positive 1, or negative 1, negative 1. And add to 2. Yes, okay, so y plus 1, y plus 1. And I encourage you to write that as y plus 1 squared. Yeah? Mr. Todd, I did all my homework. I'm already good at all this stuff. I don't know why you felt like you needed to review it. Well, I understand that this chapter is very difficult for a reason, is that we ask you to do common factoring and you go home and go, good, I'm good at common factoring. Then we ask you to do a simple trinomial and you go home and go, good, I'm good at that. I ask you to do complex trinomial, good, and you go, good, I can do that. And then when you have to decide which one to do, you're like, we didn't do any of that yet. And that's what this part of the lesson is for. And tomorrow's lesson is to go, okay, but when a random question appears, how am I going to know which type of factoring to do? Okay? And that's why I brought this up, because it had all the different types there, and I tried to warm up tomorrow's lesson a little bit. Do you have questions there? Nuh-uh. Okay, Ms. Todd, get to it. Teach some stuff for today. Okay, good. This is me teaching today's stuff. You're like, this is just expanding. It's just foiling. I'm like, I know. It's foiling some special ones. Check out these special foils. When I expand this one out, I get, let's see, x times x is x squared. X times negative, or positive 4 is 4x. And I get minus 4x minus 16. And here's all the special stuff in one line. In this particular question, the plus 4x and the minus 4x cancel, and those two x's disappear seemingly. It's mysterious looking what happens. We're so used to trinomials. In this special case, it actually ends up being x squared minus 16, which might look weird to you. And that's why I'm here today, to show you this weird looking quadratic, this weird looking degree 2 expression that doesn't have an x term. Well, the whole lesson, the whole idea of the lesson is right now, the whole idea, right in this moment. How come it happened? What was it about the situation that made this happen?
There is a negative 4 and a positive 4, so they just cancel each other out.
Negative 4 and positive 4. There's the big idea of the whole lesson. When the special case happens that the two numbers, these two special numbers we're talking about, are the same number but just change signs, you're going to get these weird looking, I want to call it a trinomial. It's not a trinomial because it doesn't have the middle term, but it could be thought of as a trinomial, maybe. Okay, more to come about all that, but here's that special case. Can you see it coming here in this one too? You got plus 7 minus 7, and so when I expand that out, and I'll do it more carefully this time, 2x times 2x is 4x squared. 2x times positive 7 is 14x. Negative 7 times 2x is negative 14x. And negative 7 times 7 is negative 49. And I want to go a little farther with this one. This one had happened again. Plus 4x minus 4x, plus 14x and minus 14x canceled. But there's something special about the two terms that are left. The 49 is the 7 squared. The 4x squared is the 2x squared. So there's something really connective about the question and the answer here. That's what I got to get to in these examples, is seeing that connectivity that, because in a minute we've got to be able to do, hopefully you can see what's coming. I'm going to try and do some questions where I'm trying to go from here to there. And to do that, I've got to recognize what I'm seeing. And if I recognize what I'm seeing, this will be the easiest factoring you'll see. This one's a little different in that it's got a coefficient up front. This is preparing you to make sure you common factor first, because things can get messy if it's got a common factor. This part, x squared plus 5x minus 5x minus 25, that's all true. And I get this. And I want to pause again, because this is me doing the teaching part of this, so that when we actually go to do these, you find them pretty straightforward. Notice what happened. X minus 5, x plus 5. I got x squared, and I got 5 squared. But one little detail, what sign is between them every single time?
A negative?
It's always negative. When this happens, we always end up with a negative between them. Let me go back to the title of the lesson, because math lessons are funny sometimes, where it's like it's a long way into the lesson before you understand the title. It's a difference, that's the negative every time, of squares. Both of the pieces were something squared. That is, when I looked at these, the 16 was 4 squared. The 49 was 7 squared. It's always something squared. That's how we'll recognize this when it comes up. Now, if there's a common factor in there, that will mess up our thinking, because 3 is not something squared, or not something nice, and 75 is not something squared. So this is just me circling back going, make sure you common factor. That should be on your test. Yeah? Yeah. I hand you your test or your quiz, and you write it on the top. You don't write your name. You write common factor first, because these questions can cause you all sorts of headache if you haven't taken care of the common factor first. Well, here's one in a general situation. We often use part D in these examples to go, well, let's just push your limits just a little bit and see what happens here. M minus n times m plus n. Your brain wants to freeze. It's like, it's too many variables, that's too many letters. Just slow it down. M times m, m squared. Then m times n is mn, whatever that is. And then minus n times n is minus, it's tempting to write nm.
Would it be wrong?
It's not wrong. It's not wrong to write nm. But mathematicians sort of agree, if we've got a bunch of variables together, let's put them in alphabetical order, only so that we all write it the same, and like terms will match up. So it's not wrong to write nm, but my suggestion is get used to writing them in alphabetical order. Instead of writing nm, write mn. And then I get minus n squared. And the same thing happened again. The first term is something squared. The middle two terms canceled, and the second term is something squared, and it's the subtraction between it. That's so important. I'm going to say that whole sentence again, because it's the vital part of this lesson. I'll put on my glasses too, to make it seem like I'm really studying this situation. After multiplying this out, the first term was something squared. Then there was a subtract, and then the second term was something squared. That's how I know I have difference of squares, to use the fancy term. So now the note explains all that technically, from a technical standpoint. The part that sometimes messes people up because they are trying to give a technical explanation of it. So here's the technical explanation. Let's see how we do understanding it. Notice all the solutions result in a binomial where the two terms are being subtracted. Let me just highlight that because that's straight from the title of the lesson. Difference, subtraction. This occurs when you multiply two identical binomials together, where in one you're adding and the other you're subtracting. So a difference of squares. If you get ax squared minus c, something that's something squared minus something else squared, you break it up, you use square root to figure out what the individual pieces are. So the first bracket will be root ax minus root c, and the second one will be root ax plus root c. What? Hold on. Let's see what it actually looks like to actually do it. Here we go. Right off the hop, x squared minus 100, and I'm going to pass it to somebody. Can somebody look at this and already factor it? They know what the two brackets are, and then we'll try and break apart what they did. Peter, you got this?
Is it bracket x plus 10?
Yep.
Close bracket, open bracket, x minus 10?
Yes. That's the moment, hopefully, where some people are like, hey, this is the easiest thing we've seen all chapter. And lots of people believe that about difference of squares. But let's break it down, just in case that was a little too quick. Austin, question?
That add to 0, not 1x?
Oh, yeah. Oh, actually, first of all, before we even go, let's doubt him for a second, shall we? I'll draw a blue line and say, I don't think he's got it right. Yeah? And let's do FOIL. What's x times x? So this is x squared. Then x times negative 10 is negative 10x. 10 times x is positive 10x. And then 10 times negative 10 is negative 100. He's got it right. We're going to get to in a second. If you're like out there going, but I don't know how he got it that fast. Yeah, I'm going to explain that very carefully in just a second. Is that what you meant, or did you mean something different?
No, I thought it was the adding and multiplying thing.
Oh, yes.
So I thought, like, that doesn't add to 1.
Oh, I get what you're saying. Right, but these are distributing and multiplying.
Yeah.
Yeah, good, good. How did he do it? Well, let me show you how the grade 11s do it, because they have tougher examples. They just put a little arrow out from the 100, and they find the square root of 100. That's where the square root, then the technical explanation was coming from. You're like, I didn't need square root to deal with 100. Yeah, I know. But if the homework tonight, instead of saying 100, says 225, maybe that's not right in your head, and you might have to break out your square root button. Question? This is why people find difference of squares so easy. He says, so you just find the square root of it, but then do plus and minus. Yeah, that's key to all this. So then this one they look at and go, okay, what was squared to give x squared? And they do a little x. X was squared to give x squared. Do you need all those extra little arrows and steps? No, no, only when they get difficult. Well, let's see if these get difficult. Is this a difference of squares? Okay, so tomorrow in reasoning lesson I'm going to go, is there a common factor? No. Is it an easy trinomial? No. Is it a tough trinomial? No. It's got two terms. It's a difference of squares. That's the final part of my lesson tomorrow. I've already given it all away. Is this a difference of squares? Difference. It's got subtract. Looks good. Are these both something squared? Is there something that squares to give 64? 8. I'm feeling pretty good. There is something that squares to give 64, which is 8. Is there something that squares to give 25x squared? 5. 5x. That term has an x in it, so it's 5x that I got to square to get 25x squared. Once you have those up there, see, writing up there, the first time I did it, you might be like, I don't need to write them up there, but it's kind of nice. You put those up there, and then your first bracket is 5x plus 8, and your second bracket is 5x minus 8. Why don't the 5s change sign? The first term doesn't have to because that's a positive number. And so we are going to use positive times positive. The second number is negative, 64. So then the 8s have to be, one has to be positive and one has to be negative. To get positive 25x squared, these both need to be positive. But to get negative 64, they need to be opposite signs. It is cool. Yeah. He said the next best thing. He said this only works if it's subtract, if it's negative in between. That's the only way this works, and that's absolutely true. There's no such thing as sum of squares. It's not like, oh, and tomorrow let's look at sum of squares. No, it doesn't work. It only works with negatives. What's happening here? My board. Let's go again. Does 49 have a square root? 7. Is it subtract in between? Yes. Does 4x squared have a square root? 2x. And by the time you write that stuff up there, you're pretty much done. Your two brackets are 2x plus 7 and 2x minus 7. And if you're not sure, you could FOIL it out and make sure you got it all right. Because it's easy to miss the 2 there when you're doing these, is to not include that 2 in there. Nice lesson. Are we almost done? Are we like?
Yeah.
2 more to go. A curveball, and then a tough one. A lot of math lessons end up like that, right? And you have to manage your emotions when that happens. You're like, I get this. I like this. And then the last 2 examples derail you. It's easy to go, maybe I don't get it. Yeah, you get it. Well, let's just extend now and go after things that might be a little bit more difficult or might cause you a little bit of trouble. 32x squared minus 50. Is it subtract? Yes. He already sees it coming. And I hope that means we're all doing a good job together this chapter, watching out for these common factors. Because this thing, 50 doesn't square root. And you might throw up your hands on the test and go, Miss Todd, you messed up. You meant to say 49, didn't you? 49 squared. So I'm like, no, I meant to say 50. And you go, okay, what else? What else? The number one thing, common factor. What's the biggest number that divides into 32 and into 50? It's just 2, yeah. And now it's 16x squared minus 25, and hopefully your eyes light up as soon as you see those 2 numbers, because those are squares. What do you square to get 25? 5. And what do you square to give 16x squared? 4x. And now we're ready to go. 2, 4x plus 5, and 4x minus 5. That was my curveball. My like, okay, let's just see what you got here. Put a little spin on it. But if you're ready for the common factor, not too bad. Oh, this is like the 106-mile-an-hour fastball now. Right after the curveball. Now you're out in your front foot because of the curveball, and then the fastball comes. Okay, this is for reals, folks. So if you got this, you're like, I'm good. Feeling good, going for after the homer. This is like me going, oh yeah? Let's do the, you could FOIL both those out and subtract them, gather them all together, and then factor at the end. That would probably take 1, 2, 3, 4, 5 lines, and the factoring at the end would be a little bit wild. Okay? Is it a difference? It's definitely a difference. It's got to subtract between. Are they squares? They're so ridiculously obviously squares that it's difficult. Yeah, it's so easy, it's hard. What's squared in the first one? That thing, yeah, that whole thing. That's what was squared in the first one. How about this? What was squared for that one? Everything. And now, maybe for the first time, I'm going to introduce some new brackets to help you manage. If you try and use brackets inside of brackets, it can confuse you. Here's my new brackets. Square brackets. Helps you manage when you've got double brackets that we're going to use here. The first set has 2x minus 4y plus the 3x plus 7y. Yeah. Then the set, wait till I finish and then ask your question. It might be a great question. Second bracket has 2x minus 4y minus the 3x plus 7y. Add in the first bracket, subtract in the second bracket. What are the things I'm adding? Whatever was squared. And I'm going to tidy that up and then pause for questions. But don't let me away with it. Stare at that long enough that you go, okay, yeah, I see where you got that. Okay, yep, I see where you got that. Because that is not simple, that simplification at the end. I'm not trying to pretend it is. It's not one of those math problems that, oh yeah, once I finish explaining, you go, oh, I get that now. That's one of those ones where after I finish explaining, you're like, I don't know. You could then FOIL, except the question said factor. So when it says factor, we're trying to move towards being factored, not FOILing it back out.
If factoring is finding the other things that add to the thing.
Beautiful sentence except for one word. the thing. I didn't mind the thing, actually. Factoring is the process of finding the things that multiply to the thing. You said that add to the thing. We want things multiplied. And you see, this is a bracket times another bracket. This is factored at the end because there's things multiplied together. So a nice short form of factoring. Factoring is make it into a multiply question. Make it into two things multiplied. Yeah? Why do we do it? Well, we're going to circle back on Monday and go after the stuff from last chapter with our new factoring skill. And we're going to find out, oh, wouldn't it have been nice if we could factor last chapter? All that stuff's going to be easier once we can factor. You'll see. We'll finish the chapter. We won't finish the chapter without looking back. Any questions about this last one? Okay, now listen. New math strategy for your bag of tricks. When this happens to you at the end of a math lesson, don't freak out. In fact, I don't even look at it that much. Go back and do the other homework questions. Get really good at difference of squares. Then come back after your skills are a little stronger and look at this one again. So don't give it too much credit until you've done some practice. In a perfect world, what would have happened? I would have taught that first part, let you work for 45 minutes. You got most of your homework done, and I would have said, oh yeah? Hey, try this one now. But our scheduling doesn't allow for that. So don't panic just yet. Do the other ones, do all the easy ones, and then when you get here, you're home free. I noticed someone's notes are out to tomorrow's reasoning, maybe by accident, and their practice quiz at the same time, which is so smart. I'm going to use the reasoning lesson to help me look at the practice quiz. I don't know if he did that on purpose, but that reasoning lesson, that's exactly what it's designed for.